Section 3 of this chapter, chapter 4, is about line of best fit. I'm not going to do an assignment for this one. You're going to have a project. The project is in the 20% of your grade group along with the quizzes. So the one project is not worth 20% of your grade. However, it's combined in with the quizzes, and you'll have more projects in future chapters as well. So line of best fit, the idea is we have this set of data here, collected some data about how many gallons it took to go a certain number of miles. And if you graph that, it looks something like this. What we're trying to find is a line that generalizes this data. They're not all on the exact same line. We're not going to find a line that's exactly through all of them because it goes up and down a little bit. It doesn't quite line the same line. They're not collinear, is what we would say. So we want to find a line that fits it the best. It looks very linear. It looks like a straight line, pretty close to a straight line, but not quite. It's definitely not a U, so it's not a quadratic. And it's nothing else. It's not a W, so it's not a quartic. So it looks like a linear line. And in our work and our examples that we're doing in this class, in this chapter, we're doing linear. So we're going to try and find that line of best fit. Just drawing a line is not very good. Guess and check isn't great. We can get close, but not really very good. And so we're going to use technology to help us with this. So that's what we're going to do here. So I'm going to exit out. I'm using a TI-83 Plus calculator. So I'm going to explain how to do this on a TI-83 Plus calculator. If you have a TI-83, TI-83 Plus, TI-84, TI-84 Plus, silver, platinum, whatever, they should all be very similar. If you have anything else, then you're either going to have to get a TI-83, 4 calculator, or figure out how to use your own to do the same thing. The other option, I'm going to put a link to this on your screen, or not on your screen, but in the project, is to go to this website here and download one. This is what it looks like. So it's a TI-83 Plus emulator is what this is called, and it looks like the TI-83. It acts like the TI-83. It does all that fun stuff, but it's not quite the same. So if you have it, great. Otherwise, I'll show you this, or give you this link. So okay, going back to the lesson. Where did it go? Here it is. Here we go. So I've got this data, and I'm going to show you how to plug it in here to find that line of best fit. When you're at your calculator, you should have a button that says Stat. That's for statistics. So you're going to click Stat, and we're going to edit. So we're going to edit our list of data. You've got list 1, list 2, list 3, list 4. If you stick with just list 1, list 2, then you don't have to worry about doing anything else. If you use list 3 or list 4, then there are extra steps you have to take. And so I don't recommend doing that. Just stick with list 1 and list 2. So I'm going to put my X values in for list 1. I'm going to put my Y values in for list 2. I'm going to have you do the same. So while I'm doing this, you go ahead. Be careful that you put the numbers in correctly. Don't skip any numbers on accident. There we go. And the Y value is 155.8. This is good TV right here. 99.7, there we go. Okay, so I've entered all that data in. Pause it if you need to take more time. Now we're going to quit. So right here it says quit. We're going to do second quit. Then we're going to go back into the statistics. And instead of editing our statistics, we're going to do some calculations. So I'm going to use the arrows. We go over to calculate. Now this was a straight line, or pretty close to a straight line. So I want a linear regression. Not a quadratic, not a cubic, not a quartic, linear. And as it says right here, this is like AX plus B. So this is like the slope and the Y-intercept. Excuse me. So scroll down to 4. I'm going to click Enter. I'm going to push Enter. If you only use list 1 and list 2, then you're set to go. So here's my my linear regression. A is 17 point blah, 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 blah. B is negative 12 point blah, 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 blah. On On the worksheet, on the project, and on this, what I'm going to do for my examples, I'm going to have you round to the nearest integer. So I'm going to have you round to the nearest whole number. 4 rounds this to 17, so the slope will be 17. This 9 is going to round this up to a negative 13, or excuse me, negative 11. So we'd have 17 as the slope, negative 11 as the y-intercept. So I'm going to go into y equals, I'm going to plot this. So it was 17 and negative 12, or negative 11, excuse me. So 17x plus negative 11. And if I graph that, it sort of is on my screen, but it's hard to really see this graph on there. So I have to change my window a little bit. So I'm going to go into window, and you're going to have to do this again in chapter 5 when we have another project. So this is how you change the window. I'm going to have my window, let's see, my lowest x value is 0. My highest x value is 11, so I'm going to go with 12 as my maximum. With scale of 1, that's fine. I don't have any negative miles driven, and my maximum is about 183, so I'm going to go with 200. That way I see everything. I'm not going to go by a scale of 1 just because it's hard to see all those ticks. I'll go by a scale of 10. Now if I graph it, that looks a little bit better for what we have here. We don't have the points on there, though. We can actually do that. If we go back into y equals, right up here it says plot 1. If you go up to plot 1 and push enter. So it's bolded here. There are the points. There's my line of best fit. That's pretty good. It goes through those points pretty well. It's pretty darn close to being right through all of them, but a little bit above some, below some. So that's the line of best fit. So the answer on the quiz, or not the quiz, excuse me, on the project, where it says what is the equation for the line of best fit, 17x plus negative 11 or minus 11 would be the same thing. You're going to be asked to plot those points. So you'll plot the points on the graph, and you'll be asked to graph that line. So you'll put the y-intercept, and you'll use the slope to graph that line. So that's what you'll do for that project. There's another thing that we have to talk about with this, though. So we have our equation, 17x plus negative 11, 17x minus 11. The other thing that we need to go over in this section, we call it interpolation and extrapolation. It's as much fun as it sounds. It's actually not that bad. It's pretty easy. Interpolation are all the values between our known values. What I mean by that is we know that 9.3 gallons gives us 155.8 miles. And we know that 10.3 gallons gives us 167.1 gallons. We don't know how many miles we get for 10 gallons. But we could probably figure it out. And so interpolation is in between our known values. So here's a question you might be asked. To the nearest mile, how many miles can the car travel on 8 gallons of gas? That wasn't one of the points listed. But we have a formula, 17x minus 11. So if we go to, I apologize about the sniffling, I've got a bit of a cold. I'm going to thank my youngest daughter for that. If we know that we've done 8 miles, I can plug that into my formula. So if I do 17 times 8 minus 11, I get 125 miles driven. Now it might not be exactly 125. It might be off by 0.1 or something like that, because this is a line of best fit. But 8.8 gave me 139, 6.7 gave me 99. So yeah, it seems about right. You know, that's right in there. And if we look at that point on the graph, that should be about right, based on our equation. So that's what interpolation is in between 2 points. What value can we anticipate having? What can we predict to have? About 126, I have 125. Extrapolation, values beyond. So beyond values. This is where we knew up to 11.6, I think, is what we knew up to, and we want to go beyond that. So we might say to the nearest gallon, about how many gallons of gas would we expect the car needs to travel 250 miles. So 250 miles was outside of this range. We only had 183. So going back here, if I use the same equation, 17x minus 11, and instead I want to know about how many gallons will I need to get to 250. I can solve this. I can add 11 to both sides of that equal sign. 261 divided by 17. So we have 1x, and 261 divided by 17 gives me about 15.4. I mean, it's a long decimal that repeats eventually, but about 15.4 gallons. 15.4 gallons is how much I would need. So that's extrapolation. Interpolation in between points, extrapolation outside of those points. And that's how we do that. So here's one more example. Pause it. Try and get this to work on your calculator on your own. Find the line of best fit and then extrapolate what grade you would expect a student who studied 6 hours. All right, I'm assuming you paused it. I'm going to go through and do this on here so you can kind of see it. And how long is this? So 11 minutes. All right, I got time. Okay, so here we go. I'm going to go stat. I'm going to edit. I'm going to clear this, so I can just go up and push clear. If you don't want to go through and delete them all, you can. So I'm going to go with my x values. I'm going to go with my y values. Go, quit. I'm going to go statistics, calculate a linear regression. And there I have it. So I have my linear regression. Remember, you don't need to graph it. I graphed it to kind of show what it was doing, but this is my linear regression. So linear regression is y equals 6. Again, I'm going to have you round the nearest whole number, or the nearest integer. So it'd be y equals 6x plus 62 would be my equation. Write that down over here. So y equals 6x plus 62. And I want to extrapolate the grade we should expect if the student studied 6 hours. So 6 hours would be my x value. So if I have this equation, this model, this line of best fit, I should be able to plug that in and do 6 times 6 plus 62 and we would expect that student to get a score of 98 points. Points or percent? Sorry, we'll check that. Make sure my label is correct. That doesn't say. We're going to go with points. So extrapolate the grade you would expect a student to study 6 hours. We would expect them to get 98 points on that exam. All right. So that's how the calculator is used. That's how you find the line of best fit. And that's what you'll do for the project.